Good afternoon, everybody, and welcome to today's free AI webinar, the AI Developers Toolkit, brought to you by Pluralsight. Artificial intelligence is everywhere. AI is beginning to transform our products, our companies, and our world. However, most software developers have not yet added these modern data-driven AI tools to their professional toolkit. So today, with the help of our very special international guest, we will look at the various tools in the toolkit, how to use AI, ML, and deep learning to solve real-world problems, and how to build AI apps in a cyber-physical system. Hello to each and every one of you. My name is Shobit Khanna, and I'll be your moderator today. Now, we still have a few people joining us in the back rows, so while we wait for them, let me take you through a little bit of housekeeping today. Please note that all attendees are muted and in listen-only mode. However, we do encourage you to interact with us today. You can do so by using the Q&A panel at the bottom of the Zoom window. We will do our best to get to all of your burning questions towards the end of the webinar. So please do keep them coming, don't be shy. Also, we love getting feedback from you. So I just want to quickly bring your attention to the exit survey, which you will receive towards the end or after the webinar. And we would love to get your feedback on today's session, as well as suggestions for future topics. Now that we've all settled in, let me introduce you to our special guest for this afternoon, Matthew Renze. Matthew is a data scientist or data science consultant, author, and a public speaker. Over the past 2 decades, he's taught over 300,000 software developers and IT professionals. He's delivered over 100 keynotes, presentations, and workshops at conferences on every continent in the world. And guys, that does include Antarctica. His clients range from Fortune 500 companies to small tech startups around the globe. So without further ado, I'd like to hand it off to Matthew, who's joining us from the US during his evening time. Welcome, Matthew.
Thank you for the introduction. All right, well, artificial is everywhere. From self-driving cars to autonomous drones to collaborative robots, we're adding AI to our products, our services, and our world. According to McKinsey Global Institute, AI is expected to generate $13 trillion in real economic value by 2030. That's a 16% increase in our current global GDP. In addition, by 2030, AI is expected to automate approximately 600 million jobs. That's roughly 22% of all jobs that currently exist today, gone in just 10 years. Fortunately, though, they're also predicting 700 million new jobs will be created by 2030, many of which will be jobs that require AI tech skills. Ultimately, this is going to have a tremendous disruption to our labor economy in less than a decade. However, most software developers, IT professionals, product managers, and executives have not yet learned how to leverage these new AI tools in their professional toolkit yet. So they don't have the skills necessary to meet the demands of an AI-first economy. As a result, they don't know what's currently possible with modern data-driven AI. They don't know how to add AI capabilities to their own products and services. And they don't know how to tell if an AI solution will provide real economic value for their customers. Essentially, they're in the dark during the single most important technology revolution of our lifetimes, a revolution that's happening right before our very eyes. The purpose of this webinar is to survey the most popular modern data-driven AI tools. We're talking about easy-to-use, off-the-shelf machine learning models that you can use today to automate a wide variety of tasks in your products and services, many of which are currently better than humans at performing the equivalent task. As an overview of this presentation, first, we'll learn about AI tools for working with tables of data. Next, we'll learn about AI tools for text. Then we'll learn about AI for audio, then AI for images, AI for video. Next, we'll learn how to wire these models together to build modular AI applications. And finally, we'll learn about AI for cyber-physical systems like robots and self-driving cars. We're going to start with the simplest tools and work our way down to the more complex and, in my opinion, the more interesting tools. Some of you will likely have seen some of the older, more basic tools that we're going to cover in the first part of the presentation. However, many of the tools in the second half of this presentation are going to be completely new and will likely seem like total magic. Though I assure you that everything you're going to see today is 100% real. So if you're struggling to stay engaged early on, just bear with me. Things will definitely get more interesting as we move further along. And unfortunately, we just have a 1-hour time slot for our presentation today, and I want to make sure that we have enough time for questions at the end. So I'm going to intentionally focus just on the most interesting and informative topics today. We're going to skip the first one and the last one, since I think the ones in the middle are going to give you the most value or most bang for your buck with our limited time together. However, at the end of the presentation, I'll show you where to go to see the full online course, which will discuss all of the topics. And we'll also provide in-depth code demos with a bunch of the popular tools as well, too. So by the end of this presentation, you should be able to identify a wide variety of data-driven AI tools. And this will help you to generate ideas for how you can quickly and easily add AI automation into your own products and services. In addition, you'll learn how to recognize the common AI problem solution patterns. And this approach will help you to identify what is technically feasible in your own products and services. However, I want to keep things simple for a general audience. So we're going to skip all the complex math, code, and vendor specifics. Today, we just want to focus on the essentials. In addition, we're also going to skip over all of the classic AI tools that have been around for years, like heuristic search, dynamic programming, and expert systems. Today, we just want to focus exclusively on modern data-driven AI tools, machine learning, deep learning, and reinforcement learning. And you can think of this presentation like an enormous buffet of AI tools. We're going to be sampling a lot of different flavors of AI today. However, there's just too many types of AI for us to taste all in one seating. So we just want to take very tiny bites of each topic today. If you find something that you like, you can always dig in deeper later. But by the end of this talk, if I've done my job well, you should feel pleasantly full, if not completely stuffed. Well, we've got a lot to cover, so we're going to get started here. But first, before we get into our survey of data-driven AI tools, let's take a quick step back and answer the question, what is modern data-driven AI? To answer this question, we need to start with what is AI itself. So artificial intelligence is a subfield of computer science that attempts to create machines that act rationally in response to their environment. An AI is any machine that perceives its environment and chooses actions that maximize the likelihood of achieving a goal of some kind. Essentially, it's just a machine that takes data as input and produces the best output given what it currently knows. Some examples of AI include computers that can play chess, robots that can vacuum your floor, non-player characters in video games, and navigation software on your smartphone. Any computer algorithm that replicates some aspect of human intelligence or natural intelligence is essentially a form of artificial intelligence. All modern data-driven AI is largely based on machine learning. So what is machine learning? Machine learning is a subfield of AI based on data and statistics. It involves machines learning how to solve problems without being explicitly programmed to do so. It does this by detecting statistical patterns in data. Essentially, with machine learning, we use existing data and a training algorithm to learn a model of the data. Then we can feed new data into that model that it's never seen before, and the model will make predictions about the new data. A machine learning model is essentially a function. It's simply a mapping from an input to an output. In the most basic case, we provide the model with data as an input, and it produces a prediction as an output. And this is very important to note because every example that we're going to see today is essentially just a mapping of some kind of input to some kind of output. Everything we're going to see is just a function of some kind. There are two main types of tasks that we can perform with machine learning models. We can either perform data analysis or we can perform data synthesis. Analysis is where we take complex high-dimensional data as input and reduce it down to lower dimensional, more abstract data as output. For example, converting text, audio, or video into a single number or label of some kind. Synthesis, on the other hand, is where we take lower dimensional, more abstract data as input and then produce higher dimensional, more complex data as output. For example, converting simple text into more complex audio or a video of a person speaking that text. Throughout this presentation, we'll group all of our models first by the type of data that they involve, and second as either an analysis task or a synthesis task. And this will help you to build a mental model of the landscape of all the various tasks that can be performed with modern data-driven AI. Finally, there are three main types of machine learning models: pre-trained models, augmented models, and custom models. Pre-trained models are off-the-shelf solutions. They've been previously trained by a third party to perform a general task and are ready to use with little or no effort. For example, Microsoft provides a pre-trained vision service that allows you to detect people's faces and images. Custom models are do-it-yourself solutions. You have to provide the training data, the compute power, and the expertise to create a model to perform your specific task. For example, if you wanted to predict customer revenue based on your company's data, you could create this model from scratch yourself. Augmented models are somewhere in between. these models are pre-trained by a third party, but you transfer the learning from the more general task that they've trained it for to your more specific task that you'll specifically train it for. For example, if you want to detect your company's logo in a photo, you could augment a pre-trained image classifier to detect just your specific logo. Now, I've ordered these three types of models by their level of difficulty and cost as well too. So I recommend that you always start with pre-trained models if possible and work your way to custom solutions only if or when necessary. All right, so now let's start looking at the survey of all of the different tools, starting with text. So first, we're going to start learning about the AI tools that exist for working with bodies of text, both in terms of analysis and in terms of synthesis. So text is how we communicate information to one another via written language. It's the primary type of data that we encounter in books, articles, and emails. As a result, it's one of the most valuable forms of unstructured data that exist in our world. Textual data are data that represent a body of text. For example, this passage from Shakespeare. We typically store textual data as an array of characters of an arbitrary length. Each letter, number, and symbol are represented as a binary value within this array. There are a variety of AI tools that we can use to perform text analysis, also known as natural language processing or NLP. These text analysis tools include text classification, sentiment analysis, entity recognition, and more. First, we have text classification. Text classification allows us to assign a body of text into two or more categories. In essence, it answers a question, what kind of text is this, or what group does this text belong to? For example, we could classify inbound emails by the department that typically handles them. We provide the model with the text contained in an email message as input, then the model produces a prediction of which department the email should be routed to as output. Text classification is useful anytime you have a collection of documents and you need to organize them into two or more categories. For example, organizing legal documents based on the type of case, classifying support tickets by the type of issue, and classifying emails as either spam or not spam. Second, we have sentiment analysis. Sentiment analysis allows us to determine the emotional sentiment of a body of text. Essentially, it answers the question, is this text positive or negative? For example, we could analyze product reviews to determine if they're favorable or unfavorable reviews. We provide the model with the product review text as input, then the model produces a sentiment score, often ranging from 0, which is very negative, to +1, which is very positive, as its output. Sentiment analysis is useful anytime you need to determine the emotional sentiment of a body of text. For example, detecting high priority customer support emails based on the customer's tone, filtering out social media posts with overly negative sentiment, or for helping you write emails with a more positive and constructive tone. Third, we have entity recognition. Entity recognition extracts name entities from a body of text. Essentially, it answers the question, what person, place, or thing do these words refer to? For example, we can use entity recognition to discover named entities in news articles. We provide the model with the text of each article as input, then the model produces a list of the named entities, their locations in the text, and a confidence score as output. In this example, the words Microsoft and Google clearly refer to their respective companies. However, the word Amazon could either refer to the company or the river in South America. So the model needs to use the surrounding context to determine which words correspond to what entities. Entity recognition is useful anytime you want to determine what entities are contained in a body of text beyond simple word matching. For example, improving document search using searchable entities, adding hyperlinks to entities in website articles, or extracting medical codes from patient diagnosis in their medical records. Beyond these three common text analysis tools, there's also a variety of other text analysis tools. For example, tone analysis, which is like sentiment analysis, but for other types of emotions. Language detection, which answers the question, what language is this? And sentiment analysis, which organizes words into a hierarchical tree representing each word, their part of speech, and their syntactical relationship. In addition to the text analysis tools that we've just seen, there's also a variety of text synthesis tools. These include AI tools like text completion, text generation, and language translation. First, we have text completion. Text completion allows us to predict missing words or upcoming words. In essence, it answers the question, what word is missing or what words will likely come next? For example, we can use text completion to predict what words a user is likely to type next into their smartphone. We provide the model with the text of an incomplete sentence as input, and the model produces the most likely text and a confidence score as output. Text completion is useful anytime you need to predict missing or future words in a body of text. For example, auto-completing sentences while you're typing, correcting transcription errors while transcribing from videos, or verifying sentence syntax by checking the probability of occurrence of each word in a sentence. Second, we have text generation. Text generation allows us to synthesize a body of text from a simple prompt. Essentially, it allows us to create entire documents just by providing a few written instructions. For example, we can use text completion to compose new emails for us automatically. We provide the model with a simple text prompt as input, and the model produces a text of a full email as output. Text generation is useful anytime you need to synthesize text-based content using a short prompt. For example, automatically generating articles for your website, replying to simple questions in tech support emails, or automatically generating an FAQ from your support tickets. Third, we have language translation. Language translation allows us to translate text from one language into another language. Essentially, it answers the question, how do I say this sentence in another language? For example, we can use language translation to convert the following text from English into Chinese. We provide the model with text in English as input, then the model produces the equivalent text in Chinese as output. Language translation is useful anytime you need to convert text from one language into another language. For example, translating your website for an international audience, translating support emails from foreign customers, or reading documents written in a foreign language. In addition to the text synthesis tools that we've seen so far, there's also a variety of other text synthesis tools, including text summarization, which reduces a large body of text into a much smaller synopsis of the text. Language transliteration, which converts words from one alphabet into words that are pronounceable in a second alphabet. And program synthesis, which converts visual descriptions in pseudocode into actual source code. And I know what you're thinking, it sounds too good to be true, but this actually does exist, and it actually works quite well for various tasks. I use it for creating data transformations, and I'm really hoping to be able to use it to automatically generate regular expressions for the coding that I do in the very near future. So as we can see, there's a variety of tools in the AI Developers Toolkit for working with text. These include both tools for text analysis as well as text synthesis. Next, we'll learn how to use AI tools to work with audio. Audio is how we hear the world and speak to one another. Audio captures the sounds that we hear and the words that we speak. And as a result, audio is essential to our understanding of the world around us. Audio data are typically stored as a one-dimensional array of numeric values. Each value represents a sample of the amplitude of a sound wave recorded at a specific time. The samples are then ordered across time to create a temporal representation of the recorded sounds. For monaural sound recordings, we just have a single audio channel and thus a single array of values. However, for stereo sound recordings, we have two channels, a left channel and a right channel. As a result, stereo audio data will contain two arrays, one for each audio channel, synchronized across time. There are a variety of AI tools that we can use for audio synthesis. These include sound classification, speaker recognition, speech recognition, and more. First, we have sound classification. Sound classification allows us to assign a sound to two or more labeled categories. Essentially, it answers the question, what kind of sound is this? For example, we can use sound classification to determine which animal produced a specific type of noise or vocalization. We provide the model with the following audio sample as input. I hope you guys can hear that. I should have double checked just to make sure it's sharing the audio. If you can't hear it, somebody please let me know in the chat window. Then the model produces a predicted category and a confidence score as output for that sound that it just heard. Sound classification is useful anytime you're trying to assign sounds into two or more categories. For example, detecting gunshots in audio surveillance systems, predicting mechanical failures from acoustical anomalies, and identifying species of animals for wildlife conservation. Just gonna check the chat window here real quick. Cool, thank you. Second, we have speaker recognition, also known as voice recognition. Speaker recognition allows us to use the sound of someone's voice to identify the speaker. Essentially, it answers the question, whose voice is this? For example, we can use speaker recognition to determine who's speaking in an audio recording. We provide the model with a sample of a human voice as input.
Hi, my name is Matthew Renze.
Then the model produces the identity of the speaker and a confidence score as output. Speaker recognition is useful anytime you need to know whose voice is speaking. For example, authorizing the user for voice-controlled devices, personalizing voice responses based on who's speaking, or identify who's speaking each line of dialogue in a movie. Third, we have speech recognition. Speech recognition allows us to convert spoken words into a string of text. Essentially, it answers the question, what's being said here? For example, we can use speech recognition to convert spoken dialogue into a written transcript. We provide the model with the following audio as input.
Hi, my name is Matthew Renze.
Then the model produces the corresponding text as output. Speech recognition is useful anytime you need to convert spoken words into text for processing. For example, controlling computers via voice commands, dictating spoken words into a written document, and adding closed captions for the dialogue in a video. Beyond these three key examples, though, there's a variety of other audio analysis tools. For example, sound detection, which identifies the beginning and end of each sound event in a noisy environment. Sound localization, which locates the source of a sound within a three-dimensional space. And song recognition, which identifies a song based on a short audio snippet. But in addition to the audio analysis tools we've just seen, there's also a variety of audio synthesis tools. These include speech synthesis, voice synthesis, speech translation, and more. First, we have speech synthesis, also known as text-to-speech. Speech synthesis allows a computer to communicate to us using spoken words. Essentially, it allows a computer to speak aloud using an artificial human voice. For example, we can use speech synthesis to read text out loud. We provide the model with the following text as input, then the model produces the following audio as output.
Hi, my name is Matthew Renze.
It doesn't sound quite like me, and it's not quite perfect, but it's getting better every year. Speech synthesis is useful anytime you need a computer to speak to a human using a natural sounding voice. For example, dictating responses to requests for hands-free applications, narrating the text contained in documents like ebooks, and for creating more natural user interfaces. Second, we have voice synthesis. Now, voice synthesis allows us to synthesize a specific person's voice using existing audio and text edits to a transcript. Essentially, it allows us to edit a person's spoken words just like we're editing text in a word processor. For example, we can use voice synthesis to change a mistake in a recorded sentence. We provide the model with the original audio and an edited transcript as input.
Hi, my name is Matthew Renze.
Then the model produces the updated audio containing the synthesized edit as output.
Hello, I'm Matthew Renze. I'll be your virtual instructor today.
Once again, not quite perfect, but just the amount of change we've seen from a year ago to today, it's going to be pretty much human, indistinguishable from the original speaker within another year or two, I'm guessing. Voice synthesis is useful anytime you need to edit a specific person's voice in an audio source. For example, editing mistakes in a recording from a podcast, eliminating the need for audio overdubs in films, and for creating natural sounding AI voice agents. Third, we have speech translation. Speech translation allows us to convert spoken words from one language into spoken words in another language. Essentially, it allows us to translate speech in real time. For example, we can use speech translation to translate spoken English to the Spanish equivalent. We provide the model with the following audio as input.
Hi, my name is Matthew Renze.
Then the model produces the following audio as output.
Hola, mi nombre es Mateo Renze.
And while that's unfortunately not in my voice, the style of my voice, I've just learned that there is a product that will do that here coming out this year, or it may have already been released. So it'll essentially do the translation, but it will maintain the style of my voice while it's doing that translation. Speech translation is useful anytime you need to translate one speaker's language into a listener's language. For example, translating conversations in real time, translating a keynote for an international audience, or automating audio overdubs in multiple languages for a video. Beyond the three common examples that we've seen, there's also a variety of other audio synthesis tools. For example, sound generation, which allows us to add realistic sound effects to silent videos. Instrument translation, which can take a song that's performed in one instrument and then recreate that using another instrument. And music generation, which allows us to compose entirely new songs from scratch, like this 100% fake Frank Sinatra song, Hot Tub Christmas.
It's Christmas time and you know
I mean, it genuinely sounds like Frank Sinatra singing that, but it is 100% fake. So as you can see, there's a variety of modern tools in the AI Developers Toolkit for working with audio. And these include both tools for audio analysis as well as audio synthesis. Fourth, we'll learn how to use AI tools to work with images. So our world is highly visual. We derive most of our information about the world through our eyes. The spaces that we navigate, the faces we interact with, and the documents we read are all processed visually. As a result, images are one of the most valuable types of unstructured data for modern AI. An image captures a digital picture of the world. However, if we zoom in, we can see that a digital image is actually composed of a bunch of tiny squares. We call this a raster of pixels, a two-dimensional grid of picture elements. We represent this raster of pixels as a two-dimensional array or matrix of numeric values. Each numeric value corresponds to the intensity of light captured at a specific X and Y position of the image sensor. For color images, we typically have separate raster of pixels for each color channel. As a result, a color image will be composed of 3 grids corresponding to the red, green, and blue color channels. Similar to audio, we can have both a monocular image, that is a flat two-dimensional image, or we can have a stereo image, which allows us to see depth via optical parallax. The depth helps us to determine the position of objects in space relative to the observer. There are a variety of AI tools that we can use for image analysis. These tools include image classification, object detection, face recognition, and more. First, we have image classification. Image classification allows us to assign an image to 2 or more labeled categories. Essentially, it answers the question, what is contained in this image? For example, we can use image classification to tag the content of an image. We provide the model with an image as input, then the model produces a category label and a confidence score as output. Image classification is useful anytime you're trying to assign a categorical label or multiple tags to a collection of images. For example, auto-tagging images on social media posts, detecting product defects via visual inspection, or diagnosing medical issues like detecting certain types of skin cancer. Second, we have object detection. Object detection allows us to identify the location of various objects in an image. Essentially, it answers the question, where are the objects located in this image? For example, we can use object detection to identify various items contained within an image. We provide the model with an image as input, then the model produces the coordinates of a bounding box for each object in the image as output. Object detection is useful anytime you have objects with multiple objects that need to be, you have images with multiple objects that need to be detected. For example, counting the number of objects in an image, detecting people in surveillance videos, or detecting various obstacles in a self-driving car. Third, we have face recognition. Face recognition allows us to identify a person contained in an image by their facial features. Essentially, it answers the question, who's in this image? For example, we can use face recognition to determine who is contained in our photos. We provide the model with an image as input, then the model produces the identity of the person or people contained in the image and a confidence score as output. Face recognition is useful anytime you need to identify people in images. For example, identifying customers as they enter your store, identifying the occupants of your office building, and tagging your friends on social media photos. Beyond the 3 examples we've seen so far, there's a wide variety of other image analysis tasks. In fact, there's so many that we can't even cover them all with just a brief description. However, here's a few of the highlights. For example, reverse image search, which allows us to find images that are visually similar to a source image. Image captioning, which generates a text description or annotation of what is contained in an image. Image segmentation, also known as semantic segmentation, which is like object detection, but detects and assigns a type of object to every pixel in an image. Other face analysis tools, which allow us to detect faces, compare faces, detect facial landmarks, determine age, detect facial features, and classify emotions. Other body analysis tools, which allow us to estimate poses, recognize gestures, count fingers, and detect adult or racy content. And other document analysis tools, which allow us to extract printed text, handwritten text, form data, and tables from documents. Now, in addition to the image analysis tools that we've just seen, there's also a variety of image synthesis tools. And these tools include image completion, image generation, image style transfer, and more. And this is where things start to get almost magical. So if you've been impressed already, prepare to be even more impressed. And if you've been like, yeah, I knew about most of that stuff already, this is probably where a lot of things showing up are will be new to most of the people in the audience. So first we have image completion, which is also known as image inpainting or content aware fill. So image completion allows us to fill in missing areas of an image with a best guess as to the missing contents. Essentially, it answers the question, what should go in this missing part of the image? For example, we can use image completion to digitally remove unwanted objects from our images. We provide the model with an image and a mask containing the content to be removed. Then the model produces a new image with that missing area filled in with sensible pixels as output. Image completion is useful anytime you need to replace part of an image with a synthetic alternative. For example, digitally removing objects from images, filling in the missing areas outside of a photo's borders, and restoring image quality to old or damaged photos. Next, we have image generation. Image generation allows us to create an artificial image given a short text description. Essentially, it answers the question, what would this thing look like? For example, we can create visual content simply by describing the object we want to see. We provide the model with a text description as input, then the model produces a synthetic image matching that description as output. And keep in mind, this isn't finding this image in a database. It is synthesizing this image from scratch. It's essentially hallucinating what a small yellow bird with a black crown and a short black pointed beak would look like. Image synthesis is useful anytime you need to create new images from scratch. For example, creating content for presentation slides, rapidly ideating on a new product design, and creating entirely new and unique works of art. Third, we have image style transfer, also known as neural style transfer. Image style transfer allows us to apply the stylistic characteristics from one image to another image. Essentially, it allows us to restyle an image in a completely different visual style. For example, we can make our photos look like paintings from a famous artist. We provide the model with a source image and then a second image containing the visual style we want to apply as input. Then the model produces a new image containing that source content but stylized in that second image's style as output. Image style transfer is useful anytime you need to restylize an image. For example, applying artistic filters to your digital photos, rebranding images for your company's visual style, and creating new VR and gaming experiences. Beyond these three image synthesis tools that we've seen, there's also a variety of other image synthesis tools available as well too. And once again, there's just too many of them to cover, but these are some of the highlights. For example, image coloration, which allows us to convert black and white photos into full color photos. Image super resolution, which allows us to zoom and enhance the image quality of low resolution images. And I know what you're thinking, this is like that thing they show in all the sci-fi shows and it doesn't actually exist. Well, it does actually exist, and it actually works quite well for certain, but not all visual magnification tasks. Depth maps estimation, which allows us to create a depth map from a two-dimensional image. Face generation, which allows us to create entirely synthetic human faces from scratch, given just a few attributes or physical characteristics. And keep in mind, that person does not exist. This is a completely synthetic face, just as a composite of those attributes. Sketch generation, which can convert a sketch of a person into a synthetic face. And once again, this is not a real person. It's just synthetically generated from that sketch. And image interpolation, which can fuse the attributes of two images together into a single image. So as we can see, there's a variety of tools in the AI Developers Toolkit for working with images, and these include both tools for image analysis as well as image synthesis. Fifth, we'll learn how to use AI tools to work with video. And in the event that the video isn't fluid enough, I may stop sharing my screen and switch it to an optimized mode just for showing videos, but we're gonna see how well it works on your end and hopefully it works well enough. So the real world isn't composed of static images. Instead, we perceive the world as a rich multimedia experience. When we combine images over time synced with audio, we get video. Video allows AI to perceive its world as a continuous and fluid audiovisual experience. Video data are composed of both a visual component and an audio component. The visual component consists of a series of static images that are all stacked over time. The audio component is synced up with the images to produce a temporally coherent audiovisual experience. Video data can either be mono, that is 2D images, or stereo, that is 3D images, technically 2.5D. In addition, the audio can once again either be monaural, which is a single audio channel, or stereo, which is two-channel audio. Adding additional audio and video channels improves our model's ability to make predictions and allows them to perform more complex tasks. With video data, keep in mind that we can perform all of the existing audio and image tasks that we just saw in the previous sections. However, the temporally coherent sequence of images and audio that are moving over time also allow us to perform some new tasks. So we're going to take a look at some of those new tasks that we can perform specifically with video. And these include tasks like motion detection, object tracking, action recognition, and more. First, we have motion detection. Motion detection allows us to identify movement in a video over time. Essentially, it answers the question, is anything moving in this video? For example, we can determine if anything is moving within a masked region of a security video. We provide the model with a video and a polygon mask for a detection region as input. Then the model produces a motion label and a confidence score for each frame of the video as output. You can see it triggers once the person, which is actually me, walks in front of that polygon boundary. Motion detection is useful anytime you need to determine if something is moving within a region of a video. For example, detecting people moving in surveillance videos, monitoring movements on wildlife and game preserves, and for helping collaborative robots detect humans moving within their workspace. Second, we have object tracking. Object tracking allows us to track the movement of an object in a video over time. Essentially, it answers the question, how are these objects moving over time or within each frame of the video? For example, we can use object tracking to track the position, velocity, and acceleration of moving objects in a video. We provide the model with a video as input, then the model produces a sequence of bounding boxes and the corresponding object ID for each object that's being tracked as its output. Object tracking is useful anytime you need to know how an object moves over time. For example, tracking people walking in a surveillance video, following the faces of moving participants during a video call, and avoiding pedestrians in a self-driving car. Third, we have action recognition, also known as activity detection. Action recognition allows us to classify various actions as they're occurring in a video. Essentially, it answers the question, what's happening in this video? For example, we can use action recognition to understand human activities occurring in a video. We provide the model with a video containing human activities as input, then the model produces an activity label and a confidence score as output. Action recognition is useful anytime you need to detect what's happening in a video. For example, detecting unlawful activities in a surveillance video, analyzing activities occurring in sports videos, and collaboration between humans and robots. Beyond the 3 video analysis tools that we've seen so far, there's also a variety of other video analysis tools. For example, Optical Flow, which allows us to track the path of moving objects over time. Gait Recognition, which allows us to identify a person based on the way they walk. And lip reading, which allows us to convert the movement of lips into movement of lips from spoken words into text. And lip reading is one of those tasks that the machines are now better than human beings at doing this lip reading task. So in addition to the video analysis tools that we've just seen, there's also a variety of AI tools for video synthesis. For example, video interpolation, video prediction, video to video transfer, and more. First, we have video interpolation. Video interpolation allows us to predict missing video frames given both previous and subsequent frames of a video. Essentially, it answers the question, what content should go in this missing video frame? For example, we can create slow motion footage from existing regular speed footage. And I'm not sure how well this is showing up on your end, but one video is very slow and jerky, and the other one should be very smooth slow motion video. So we provide the model with a low frame rate video as input, then the model produces a high frame rate video as output. Video interpolation is useful for a variety of video editing tasks. For example, upscaling low frame rate videos to high frame rate videos, restoring old film strips from manual crank cameras with inconsistent frame rates, and smoothing out multiplex security video footage where they're putting multiple frames, ordering them one after another on the video tape or on the video device. Second, we have video prediction. Video prediction allows us to predictively synthesize future video frames based on a few preceding video frames. Essentially, it answers a question, what is likely to happen next in this video? For example, given 10 frames of this golf video, we can predict the next 30 frames. We provide the model with a few frames of video as input, then the model produces a prediction of the next few frames of video as output. Video prediction is currently an active area of research, so there aren't many practical applications yet. However, you can imagine how this tool will likely do some pretty interesting things in the next generation of video editing tasks or video generation tasks. Third, we have video transfer, also known as video to video transfer. Video transfer allows us to synthesize entirely new videos from more simplified input videos. Essentially, it allows us to create entirely new videos from scratch. For example, we can use semantically segmented video, like we saw earlier, to generate a new video from scratch from that semantically labeled video. So we provide the model with a video containing semantically labeled pixels as input, like you see there. And then the model's going to produce a realistic video that represents those labels as output. And once again, it's almost difficult to tell that that's not real, like that's a completely synthetic video that's being generated right there. Video transfer is also an active area of research, so there aren't currently many practical applications. However, once again, you can imagine what we might be doing with this technology in the very near future. So beyond the three examples that we've seen so far of video synthesis, there's also a variety of other AI tools for video synthesis that include video completion, which is like image completion, but for motion videos. It completely removes whatever object you want from that video. Video face synthesis, which allows us to create synthetic videos of people speaking. And once again, this person does not exist. That's completely synthetic. Video pose transfer, which allows us to create synthetic videos of people's movements. Once again, the output person doesn't actually exist. And video lip syncing, which allows us to apply the lip movements from one audio track to another video track. And I'll play this and hopefully it stays in sync as you're watching this over the internet.
To help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates good new jobs.
So you can see how important it is that the general public really needs to understand what is currently possible with these new AI tools, because obviously nefarious actors wanting to use these kinds of technologies to dupe the public is a very serious potential issue. While it hasn't happened to the public at large, this type of technology has been used to fake executives and transfer money from bank accounts and a couple other scams as well too, which I won't go into. But if you're interested, ask in the Q&A. I'd be happy to fill you in on. Actually, maybe I shouldn't tell people how these things are being used nefariously. But as you can see, there's a variety of tools in the AI Developers Toolkit for working with video. And this includes both tools for image analysis or video analysis, as well as video synthesis. All right, so finally, we're gonna learn how to use these various AI tools to build modular AI applications. So all of the tools we've covered so far solve relatively simple and isolated problems of perception and cognition. These standalone models might be enough to add a new AI feature to an existing product or service. However, many real-world problems require more complex solutions than just simply mapping from one type of data to another. There are numerous cases where we may need to combine multiple AI models together to create a full application. For example, an application that detects both the tone of our emails as well as our spelling and grammar, or an application that listens to voice commands and provides voice responses, or an application that both identifies the person's face and the actions that they're performing. So as we've seen several times now, modern data-driven AI is all just a function. We're just training a model that can map some kind of input to some kind of output. We saw how we can apply this general pattern to analyze tables, text, audio, images, and video. Technically, we skipped over the tables, but I'll show you where to go for that. And we also saw how we can use the same pattern to synthesize new text, audio, images, and video. However, this is just the beginning of the types of problems that we can apply this pattern to. There's a multitude of other types of sensors and actuators that exist in our world. In addition, just like mathematical functions, we can combine and compose these models together as well. We can combine the output of multiple models together to make more powerful predictions. This allows us to make predictions that were not possible using a single type of input data alone, or to improve the accuracy of a prediction by fusing together data from multiple overlapping sensory inputs. For example, we can combine both images and audio from a web camera for user recognition. Using both a user's visual appearance and their voice allows us to more accurately identify a user. Or a common scenario we see in self-driving cars is sensor fusion between the image from the cameras, the radar, as well as the ultrasound or potentially LiDAR. Fusing all of those sensors together gives us a much more accurate prediction of what is in that environment. We can also chain together multiple models so that the output from one model becomes the input to another model. This allows us to apply AI to multiple layers of data operating at various levels of abstraction. For example, we can chain object detection and image classification together to perform object classification. The object detector will locate the objects in that image, and then next we'll crop the images within each of those bounding boxes. And then the image classifier will classify the type of object contained in each cropped image. Many real-world AI applications combine and chain various models together to form an AI pipeline. We take some complex high-dimensional sensory data as input, and we reduce it to a single action, decision, or unit of data as output. You can think of it a lot like building AI systems with Lego blocks. You can mix and match these various AI models together based on the inputs that you have and the outputs that you need. Unfortunately, most AI models don't just magically snap together though, so we typically have to glue these AI bricks together using a bunch of code. Interestingly, there's a way that we can avoid needing any of these AI building blocks or the code in between them at all. We can build what's called an end-to-end AI application. So with modular AI, which we just discussed, we're wiring a bunch of small, highly specialized machine learning models together to solve a specific problem. With end-to-end AI, we're training a single large machine learning model to perform all of the same tasks at once. And there are various pros and cons to each of these two approaches to creating AI applications. Modular AI systems are easier to create, maintain, and debug. However, they require domain expertise and lots of code to wire these modules together. End-to-end applications are more efficient, more powerful, and less biased. However, they're much harder to create, require much more data, and they're not transparent at all. So my general advice is to always start with a modular AI application. Start by decomposing a problem into its constituent subproblems, then solve each smaller subproblem with a specifically focused machine learning model. Finally, you can wire the various models together in order to create a full solution. Once you've solved the problem with the modular approach, you can always upgrade to an end-to-end system later. However, now you'll have the benefit of being able to use the modular application to help you train, verify, and debug the end-to-end application. And this can be a very powerful 1-2 combo for solving complex AI problems. However, this is way outside of the scope of this presentation. So unfortunately, we'll have to end this part of it at that. But as we can see, both modular and end-to-end AI applications are powerful tools in the AI developer's toolkit. All right, so let's wrap things up and learn where to go next for more information so that you can take your next steps on your AI journey. First, I recommend that you watch my full online course called The AI Developer's Toolkit on Pluralsight. It contains everything that we covered today, but it goes much more in depth. It covers the pieces that we had to exclude due to a lack of time, and it provides code demos for all of the popular tools out there. I've got code demos for Microsoft, Amazon, as well as Google, and I show how to do it with both client SDKs and REST APIs. So it's very, very exhaustive in terms of showing how these tools function on the various platforms. Plus, there's also additional learning resources with this full course as well. So please check it out and be sure to share it with others if you thought this presentation was valuable. Second, I recommend that you learn more. I have several other online courses that cover the basics of artificial intelligence, data science, and machine learning, which are all fundamental to kind of understanding this new landscape of AI. Everything is based on a foundation of data science now, and then they have machine learning built on top of that, and then AI seems to be built on top of our machine learning. In the event you don't have access to Pluralsight, I believe they're going to, there's a slide at the end that will offer you free online access. Otherwise, just send me an email at the email address on the last slide, and I'll be sure that you get free access for 30 days. Third, I recommend that you practice. Now, knowing what a deep neural network is great, but being able to actually train a deep neural network to detect fraud or a human face is very different altogether. So if you'd like some hands-on experience, here's a few resources that I recommend to get started with these new AI tools. There's some simple demos like Lobe AI is really good, TensorFlow Playground, and Teachable Machine. You can also work with the cloud APIs. Once again, I show code for this in my course for Google, Amazon, and Microsoft's equivalent AI services. And if you're interested in working with the code or models, you can go to Deep AI, Model Zoo, or Papers with Code is one of the resources I'm constantly going to find solutions to a lot of these problems. Fourth, be sure to check out my website. I have tons of free articles, videos, and courses on this topic and more. I also offer on-site training and consulting services to help businesses and teams get started with AI, data science, and machine learning. Fifth, I encourage you to engage with me and the AI learning community. So please be sure to rate this presentation if we have the ability to rate it. Ask questions during the Q&A, send me comments via social media, and please be sure to provide me with feedback on this talk, either during the Q&A session in private or on social media. Just let me know what you liked about this presentation and what things you think I could do to improve it for next time. I take your feedback very seriously and I use it to improve each and every one of my presentations. Finally, to quickly summarize, today we learned about the most popular tools for the modern data-driven AI developers toolkit. We learned about AI tools for text, AI tools for audio, AI for images, AI for video, and finally, AI for applications. There are tremendous opportunities ahead for those who are willing to invest in the future of AI. It's easier now than ever to start working with these modern data-driven AI tools. If you're a software developer or an IT professional, the time to get started is right now. So, what are you waiting for? Start building your AI developers toolkit today. Thank you. All right, I think it's time for Q&A.
That's fantastic, Matthew. Super insightful. A few creepy things for me personally, but that is the world that we live in, and it's only going to get creepier and more realistic, isn't it?
Yep.
Look, thank you very much for that. Before we get into Q&As, and obviously we wait for people to put their Q&As through. Once again, just a quick reminder for people to fill out the exit survey once it does hit your inbox. And like Matthew said, you can, we would appreciate if you rate the topic, give us, further suggestions for future topics, and just general engagement. That would be fantastic. And again, in terms of if you are looking at trialing the Pluralsight platform, we can certainly help you out. With getting a free trial. You can access that on pluralsight.com, or you can reach out to me on my email, which is currently in your chat panels, and I can certainly help you out with that as well. Now, in terms of questions, Matthew, we've got a question here. How do we ensure that we use these tools in an ethical and a responsible manner?
That's an excellent question. So, and that's a question I get asked quite often as well, too, because I think with all of the excitement about AI, there's also a lot of concern. People are seeing the potential for these tools to be used in not awesome ways. And I mentioned a few of the ways that I've seen them being used either unethically or illegally. And there's a lot more. In fact, the number of ways people will be able to misuse these new AI superpowers is just going to continue to grow almost exponentially over the next few years. But there are a lot of things that we can do to minimize the risk to society and the risk to our businesses by obviously following legal guidelines when they're put in place. But unfortunately, our laws are typically several steps behind our technology at this point in time. So we need to be thinking ahead of the legal system and be thinking more about what feels ethical or moral to us. So for example, making sure that we're not accidentally biasing our data. It's really easy to create biased AI models, either accidentally or intentionally. And when you bias these models, it can affect the lives of millions of people. So we need to make sure that we're doing things to inspect the potential for bias in the data and to minimize bias by making these tools as explainable and as transparent as possible. If AI becomes this black box that no one can question, how is anyone going to get any recourse when it makes a decision that harms somebody? And so we need to make sure that our AI is explainable, unbiased, and as transparent as possible. The rule of thumb I use is if you can explain to a judge how your model made its decision, it's transparent. But if you couldn't explain it to a judge or the judge simply wouldn't understand, then you probably have a model that's too complicated or is not transparent enough in order to be used in public.
That makes absolute sense. Thank you. Got another question here. From your personal point of view, what are you personally looking forward to in the short and long term with AI and ML?
So in the short term, I think right now the things I'm most excited about are GPT-3. So I've played around with GPT-3 quite a bit. For those of you that are unfamiliar, it's OpenAI's largest language transformer model, which is the thing I was saying. You just type a simple text prompt and it can generate a full email. Like I say, write a quick email to OpenAI thanking them for creating GPT-3, and it'll be like, "Dear GPT-3, thank you for blah blah blah," and it'll just go and fill in all the details. And you can train it on, it's trained on public data sets, but you can also train it on all of your previous emails as well too. And then it will use your previous emails to learn your style of language and your response. And I think we're going to see this integrated into so many products here in the very near future. The longer horizon, though, is something that I'm really excited about now. Is something called self-supervised learning, which is this idea that rather than having to have humans train these models, we essentially find some structural aspect of the data that allows to learn itself. For example, we just, we take images and then we just blank out a little block or two and have the image fill it in. And as it's doing that, it's learning kind of the foundational structures of visual perception. So once we've built a model that can do that really well, we can then use transfer learning to have it do something else, like have it detect human faces or detect our logo, our company logo. But we didn't have to send millions of images of our company's logo to train the model. We just trained it on a bunch of images, laying around. But it's that self-supervision that really dramatically reduces the amount of effort. And beyond this, there are so many things I'm really excited about now. But yeah, I'd be more than happy to chat with you about them.
That is awesome. Yeah, a personal note on that actually is that something that relates to identifying a spike in an incident rather than seeing the entire lay of the land. So, for example, if it's in an autonomous car, rather than interpreting all the data, that's business as usual. When an actual spike happens, is when the data gets read and it learns from it.
Yeah, so you can use the concept of attention or anomaly detection in combination. So, for example, self-driving cars, anytime a human being takes over control, that is a data point that's really valuable because everything before and after that human took control typically indicates that the car may have done something wrong. And so if you can identify those spots, you can then learn how to handle all those edge cases. But then beyond that, we just simulate these things now. So in fact, NVIDIA just announced their Omniverse here, was it yesterday during their keynote? And the idea being that rather than having to drive these cars in the real world, we essentially just simulate the real world now with a fidelity that's good enough to train the foundation. We start with really simple physics, and then we can make the physics get gradually more complicated and more computationally intensive as it learns the basics and works its way out to the more complex edge cases. Then we just simulate every possible edge case, like an old lady chasing a chicken across the road, something you wouldn't see, in your normal driving experience, to figure out, well, how do you handle that? Do you swerve to hit the chicken, or can you avoid hitting both of them? Or I swerved to not hit the old lady is what I meant to say. But you know what I mean? Scenarios that you wouldn't normally see in even a single human's lifetime. But we can simulate all of these things now and just throw randomization into the environment just to see how it handles all of these cases.
Amazing. I've got another question here. When do you think AI will be able to create websites and applications, and what this might mean for developers?
Well, in some cases, it already can. So it can build components or parts of websites. And by that, I'm mostly talking simple applications or simple visual components to a website. For example, with GPT-3 right now, I can type in, create a page that looks like Google's homepage with a to-do list, and I can check off. And when I check the button, it will then remove it from the task list. Like, it can build that application. It'll script out the HTML, it'll script out the JavaScript, and it will functionally behave as you would expect it. You can't go super complex with this yet, but we're getting to the point where before too long, we'll probably just be able to write little modules in natural language. And so each of those modules will then be able to be wired together. So we're keeping the complexity within small little units and then wiring that complexity together to solve much bigger problems.
It's amazing. I'm guessing that that question's come from a job security point of view. So let me personally build upon that for you.
Yeah.
How can
I think what you're going to say is, how do we, prevent this from being disruptive? So no matter what we do, there's going to be some disruption to our labor economy. And we saw this with the agricultural revolution, with the industrial revolution, with the IT revolution, and we're going to see it with AI as well. But what you can do is recognize that humans combined with machines are still more powerful than individual humans or individual machines. For example, I don't think we're going to see doctors be replaced by AI systems anytime in the near future. However, we're currently seeing doctors using robots, to assist with like laparoscopic surgeries. I think before too long, doctors will be consulting AI diagnostic systems in order to check their thoughts. Or what I actually believe might happen is that a doctor will make his diagnosis and a machine will make their diagnosis, blind. They won't know what each person's decided. Then they'll compare the answers to see if they match. If they match, they'll move forward with the procedure. If they disagree, they'll probably pull in a third human expert, not knowing which made the decision, whether it was the machine or the human, so it's not biased. And then they'll make their own diagnosis to do a tie-breaking scenario. But essentially the idea being that as like a software developer or IT professional, if you learn how to leverage these AI tools, you can essentially be 10 times more productive than without the tools. And we're not going to be automating software developers away anytime soon. In fact, I think the job market for developers is just going to continue to grow. But there are many jobs that are going to be disappearing soon. I have a talk called Preparing Your Career for AI that goes in depth to discuss this. And I've got like a whole list of like, the 20 jobs that they're expecting to disappear in the next 10 years, 10 to 15 years, I think. And then the number of jobs that they're expecting to grow at pretty much exponentially over the next 10 to 15 years based on technology and trends.
Very interesting. Thank you so much for that. And again, if you are looking at how you can perhaps complement and work side by side with AI, have a look on the Pluralsight website. Plenty of courses to go by, including Matthew's courses there as well. So we have reached the top of the hour. We are past the top of the hour. So thank you guys very much for joining. Apologies if we were not able to get to your questions today. We will do our best to follow up with you after the webinar. I'll share them with Matthew as well, and do connect with him so you can be in communication with him directly as well. Any further questions, you can reach out to me directly or through the exit survey, which you'll receive later. Thank you very much, Matthew. It's been an absolute pleasure, personally for me as well, and just for the entire audience, I'm sure as well. I'm sure it's time to sign off and perhaps get a bite, go to bed. So thank you, appreciate that.
Thank you for having me. I look forward to doing it again.
Absolutely, mate, absolutely. And thanks to all of you guys for joining. We will see you very soon in the next one. Have a great day. Bye-bye.